Hi there. All right, what I'm going to do is I'm going to go through a couple of these problems and I'm going to teach you something called the fundamental theorem of calculus. This is how you're going to do the homework problems tonight. All right? So I want you to focus on this first one right here. This problem right here. Okay? This is the integral. And if we were to pretend those endpoints weren't there just for a minute and just focus on this part that we know how to deal with, just like that quiz, the first quiz, that would be negative 1/2 x squared plus 4x. What have we done? We've just taken the antiderivative. Now, normally we would put a plus c on, but this is called a definite integral, and I want you to watch what happens when we plug 4 in. Now, f of 4 comes out to be 16 divided by 2, and then the negative there will be negative 8 plus 16, which is 8. And notice that f of 0 is 0. So notice that those two numbers together make 8, which is the area. Here we have the fundamental theorem of calculus. Now let's focus on this problem next. Same expression, except our lower bound is negative 1. Let's watch what happens. Negative 1/2 x squared plus 4x from 4 to negative 1, or negative 1 to 4. Let's plug in 4 again. We would get negative 1/2 times 16, which is 8, or negative 8, plus 16, which is 8. All right? Now let's look at what the answer is. The answer is 25 halves. So let's see how that f of 1 comes into play, or f of negative 1. If we plug negative 1 in, square it, you get 1 times negative 1/2 would be negative 1/2 minus 4, which is negative 4.5. Now let's think about it. We have an 8 and we have a negative 4.5. And the answer comes out to be 25 halves. Watch this. Let's watch what f of 4 minus f of negative 1 turns out to be. 8 minus negative 4 1/2, which is 8 plus 4.5, which is 12.5, or 25 halves. The same answer we just got here. This leads us to the first fundamental theorem of calculus. The fundamental theorem of calculus says to evaluate some antiderivative of a to b f of x dx, I'm going to use little f of x to represent the derivative. I'm going to use capital F of x to represent the antiderivative from a to b. And then what you do now is you plug in b and you plug in a and you subtract them. Now this is not an I don't get it kind of thing. This is just how it works. Step 1, take the antiderivative. You know how to do that. Step 2, plug in the endpoints. Step 3, subtract them. Now here's problem 16. Okay, this was a two-piece problem. So let's integrate each piece. So the first one, we know that this would become 3x. And we know the next one would become negative 3 halves x squared plus 9x. Now the first one I'm going to integrate from 0 to 2. And the second one I'm going to integrate from 2 to 3, because those are the endpoints. Look at the endpoints here, and that's what I put here. Look at this endpoint and this endpoint, and look at what I put here and here. Then what we do is we plug in the upper value minus the lower value. So for the first one, that would be f of 2 minus f of 0, which is 6 minus 0, which is 6. And look what we have right here. The area right here was equal to 6. Okay? And the second half would be plugging in 3, which would give you, let's see, f of 3 minus f of 2. If you plug in 3, you get negative 27 halves plus 27. Now plug in 2. 2 squared is 4, 2, negative 6 plus 18. Okay? 27 halves plus 20, negative 27 halves plus 27 is 27 halves, minus negative 6 plus 18 is 12. That is common denominators, 27 halves minus 24 halves, which is 3 halves. Let's go back to our picture. Oh, look, 3 halves. So the answer would be 6 plus 3 halves, which is 15 halves. Let me go through just another example for you. Now we don't have to graph. Now we can simply use the fundamental theorem and find the area. So the antiderivative of x squared would be 1/3 x cubed. The antiderivative of 4 would be 4x from 2 to 5. Now we're going to take f of 5 minus f of 2. F of 5, when you plug 5 in, you get 125 thirds plus 20, minus, when you plug in 2, you'll get 8 thirds plus 8. Now, to do this kind of quickly, what I'm going to do is this. I'm going to say that's 125 thirds plus 20 minus 8 thirds minus 8. And you can collect the way you want. I, however, am going to collect those two and get, that should be 117 thirds plus 12. That's from the 20 minus 8. And 117 thirds simplifies. 39 plus 12 is 3951. Okay? So that is what you're going to do now. You're just going to apply the fundamental theorem of fundamental theorem of calculus. This rule right here. Plug in B, plug in A. All right? So, make sure you have this in your notes. What you're going to do during class today is you can work with someone else on the homework assignment. Okay? It's on the backboard. Any questions on last night's homework, we'll go over them tomorrow. The area problems, we'll go over those questions tomorrow. All right? Have a good night. See you. Bye-bye.